Good morning, everyone. A little bit raspy this morning. Obviously saved you guys the coffee stir. Hope everyone is doing well. So today, what are we doing today? We are going to breadboard up this circuit, and then we are going to make sure it works and then assemble the finished product and then put it all in here and should be good to go. How's it going, Franco? Oh, thanks for finding the missing Raspberry Pi. So you said, there it is. You found it. I'm all right. I'm good. It's a gloomy day today. It's quite it's raining, but it's going to be hot this afternoon. So we're trying to tolerate the cold house without turning on the heating so that we can, you know, not have to use the AC this afternoon. It'll be 26 degrees Celsius. And 26 Celsius is 26 C2F. 78.8 degrees Fahrenheit. Overcast and raining. Oh, that's interesting. Across the globe. So yeah, it is a bit chilly here, and it'll be a bit warm later. That's what you get with Canada. You get both. Okay. So let's do it. Are you guys zoomed in? No, you were zoomed out. Okay, so it also seems like my back is getting slightly better because yesterday it hurt less than last week it did. So that's good. Did I just put my box underneath here? I did. 2N2907. Look at how many 2907s I have. So this was a case of when I was ordering on eBay, I ordered two loads of 100 by accident and they all showed up. And I used 2N3907s far less than I use 3904s. So I'm almost out of 3904s. I probably have like 30 left. I have like probably 180 2907s. Yeah, my back seems to be improving. So this is a 2N7000. This is the 2N2907A. And so let's set this up in the breadboard. Okay, and the 2N7000. There we go. I need to get the pinouts for both of those. So 2N 2907A. Okay, and then the 2N 7,000. Okay, and then we'll go like that, and like that, like that, and like that. Oh, you guys can't see. Making myself a little reference diagram here. Okay, 2N2907 pinout. It is EBC. Good morning, Mr. Audi. Is it Odie or Audi? And then the 2N7000. SGD. SGD. Okay, and then I think this is source, right? No, source would be the opposite. This is SG. Oh my God, that's on G. This is drain. This is gate. And then this would be, I think the emitter always has the, I never remember, emitter base collector, pretty sure. OD, okay, OD, like Odyssey. So that should be the finished diagram. We're gonna test out the resistor values. I'm actually curious to see if AI has any opinions. Let me take a photo. I'm gonna just ask Gemini, look at this diagram. I am trying to get a PWM signal on the SIG line. From 0 to 12 volts. What do you think of this diagram? The resistors have question marks because I haven't prototyped it yet. Oops, not camera. Gallery. I'm asking AI to see what it says. I'm curious because I think this will work. I don't think there should be any voltage drop from the 5K resistor because it's going to a high, never used MOSFETs, use relays. Yeah, but just it's PWM, so I need a better solution. But I don't think there'll be any voltage division because this is going to a high impedance input on a module. It won't give you a 0 to 12 volts. There are two fundamental designs. You have the emitter tied to 5 volts. Hold on a sec. higher than the source. Connect the 12 volts of the drain to 12 volts. Take your output directly from the drain. Oh, that's interesting. AI is saying this won't work. Put it on a test board and tweak it with a scope. Well, I don't need a scope really for this. It's making a good point here, okay? Something I overlooked because I don't use PNP transistors very often. So to turn on the 2N3907, I will need to give this a low, and so it'll turn on. But then to turn it off, I'll bring this high. However, 3.3 volts is as high as it can drive. And so there won't be enough threshold. There'll still be 1.7 volts. So this won't turn off. And yes, good morning. No, you don't need a scope. You just need a multimeter. That's a good point. Could I instead... Okay, let's... What if we do this? What if we do like that? Okay, and then I never know where the frickin' stupid arrow goes. From source to drain. Like that. Like that. And then like that. And then obviously the body diode, which I always forget as well. Okay. So, what if we do this? And then we tie so then I just don't know if plus 3.3 is enough to turn on. Let's check the 2N7000 data sheet. We don't have signal problems. We have gate threshold, or, well, we had base threshold issues. There's no signal problem. Okay, screen 2N7000 data sheet. Absolute maximums. VGS 2.1 volts to 3 volts. That could work. Good morning, ITT. Yeah, it's just a variable voltage I need. So I do like dropping the complexity. But so what I was thinking was using a transistor to drive the gate harder. But actually, I think this will work. I might have to invert the logic though. Okay. I think we're going to go with this. That's the funny part is I literally took a photo of I took a photo of my diagram and sent it to Gemini. Okay, so let's use a base resistor and then 12 volts. We're going to grab a resistor there too. Need to make this a little bit clearer. Okay, I'm going to draw my like that. Like so, and then this to ground. And then I need a, oh, no, not from here. Oh yeah, from here. Yes, from here. Okay, so this, and then I need a pull, I want it to be default off. No, default on. So when it's on, the voltage drop across here will be all 12 volts. When it's off, the 12 volts will come to here. So we're going to have to invert our logic. So when the MOSFET is off, yeah, I think that's good. So basically, when the transistor is when the MOSFET is on, it will shunt this circuit to ground, which will then create a voltage drop here, which will then make this line 0 volts. But when it's off, no 12 volts can find ground, so it'll be 12 volts on this line. Default on will be full throttle, won't it? When nothing's powered up, yes. But if this is up to, if this is pulled up, which I can do internally, if this is pulled up, it'll be default on. What doesn't seem correct, Jackie? The drain. What seems wrong? I'm well open to being wrong. I'm not a fan of it being full throttle, obviously. Ouch. You got a feeling? Okay. So you're making me nervous. So I asked AI, and AI said it's fine. Anyways, we're gonna prototype it. We're gonna check it. Always check your crap. Okay, so D15 2N7000. We're gonna put this back. Yeah, let's build it. I'll use pull up in code instead of the mechanical pull up. I'll use a mechanical pull up for now. Definitely. Just double checking. I want to pull up to default the MOSFET to on. I want to default 0 volt. Okay. So we got our voltage dividers here. That's good. Okay, so gate. I mean, you could get the magic smoke here. Let's do a poll. Start a poll on first use of this circuit. Will the magic smoke escape? Yes. No. There we go. Vote in the poll, folks. Okay, so we got to hook up to D15. Where is D15? It's down here. I'm going to hook up over here. You know what? I'll prop all this stuff up so you guys can see better. Okay, so from the 12 volts, I guess this rail will be our 12 volt rail. Breadboarding. Oh. Actually, we need resistors. What's our resistor value? 3.3 volts is not a lot, so I think I'm going to use like a 220 ohm or something. So 220 ohm for the gate, or yeah, the gate resistor. I don't want anything too high. Two. 2.2 ohm. Well, that's small. 270. 22K, 7.5K, 3.3, 2.2K again, 270 ohm again. I have twice 270 ohms. 180K, 7.5, 560, 4.7, 680, 75, 4.7, 220 ohm. Ohms. Did you see that new 2 nanometer processor chip through hole is going to be the way of the Brontosaurus? Yep. I have not, but like the writing's been on the wall for through hole for a very long time. In fact, I pretty much stopped buying through hole components myself, and so it's a little bit limiting to build circuits in through hole and not have a PCB. So I'm happy that I have through hole parts in stock, because this project would take too long to order a PCB. Okay, so 220 ohm. So let's just put that in 220 ohm. Probably want a 10K pull up. And that pull up needs to go up to 3.3 volts. Okay, I usually use a fairly high resistance bring back valves. The thing that through hole will always stick around for is the fact that new process nodes are expensive. Like, there's never going to be a 555 timer made on a 2 nanometer process. It's just so expensive. Okay, so we've got 10K. And then probably want a nice and safe 4.7K. 4.7K. What's the temperature in here? It is 19 degrees. Here. $4.7K. Bought a big stash of tubes last week. I like tubes. I like toidles. Yeah, 4.7 to the drain. I think that's the drain. Drain. And then the source is straight to ground. Grew up using valves for projects, then worked on old radio repair shops in the 80s. So one thing I didn't realize, I always assumed tubes were like wall voltage, like mains voltage. It's not until I had Usagi on my podcast that he's like, no, I use like 2.5 volt tubes for a lot of my projects. I was like, what? 2.5 volts? How's that possible? Okay, so plug into here and then plug into the shared ground. I need to ground also the micro. Yeah, they are DC. Yeah, they're DC. I didn't know. I thought they were high voltage, always. Right? Because you hear the horror stories of like people opening up old TVs that have tubes and whatever. But that's just because they're plugged into the wall. Okay, that's the division, that's the division. So we need our plus 12 volts here. And then we'll see what happens. So let's turn on power supply. Burn the asbestos off your grabber tool. Okay, so this needs 12 volts. So let's put this in first. Let's finish the poll. Wow, you guys believe in me. 3 of you at least. Okay, so we need a ground and a power. Unlimited power. Oops, 1 wire. 2 wires. Probably need a secret 3rd wire for the multimeter. Oh. Yeah, my back isn't healed, but it is getting better. Okay, so we're gonna need to ground. Oh, I have a ground pin here. Ya idiot. Don't ya know? Okay, ground. My sarcasm is undeniable. I don't remember what I said that was sarcastic, but I believe you. ground. So I'm going to grab, this should be 12 volts. Like so. We're going to turn on the DMM. Okay. You guys can't see that. There we go. Okay, and then we're going to feed 12 volts to here. Okay, so I've got 0. Right? And then I can touch one of these. Okay, that did nothing. Let's try the other one. It's doing nothing as well. Okay, let's think of this critically here. So what does the gate look like right now? Gate is being pulled down. Okay. So we need to increase. Oh, okay. Here's a problem. No, that's not a problem. Okay, let's just plug this one in to the 12 volts and wait. So that's clearly not increasing PWM. Also, is anything getting hot? Is that warm? Don't know. Okay, let's plug this one in. It's clearly not increasing in PWM. Okay. Oh, you know what would help? If I turned on the power supply. Now is there any smoke in here? So we've got 12 volts on our signal line. And that is doing nothing. That is also doing nothing. What did you say? They're DC. I don't know. I didn't see you say anything there. Oh, well, first of all, we're not in the right holes. Right? Because I think I'm supposed to use pins 1 and 2. So let's try that again. Okay, so that is not dropping our PWM. How about this one? Okay. Let's go take a look at the code. I'm just going to double check everything here. So power flows to the drain of the MOSFET. It does indeed. The gate, well, I can check the gate behavior right now. So right now the gate is being pulled low. So right now the gate is being pulled low. I'm going to see if I put 12 volts onto here. Just above Jackie's last comment. Is it 12 volts or not? Okay, gotcha. Okay, so clearly it's not PWMing up. Am I in the correct hole? Yes and yes. Okay. So now let's remove this. So far, the gate is still not moving. Okay, let's just check. Okay, let's check if I... It smells like something is getting hot. What is... Nothing. 0.9 volts. Why would my voltage divider output 0.9 volts? What about the other one? Okay, that one's doing 2.8. So I must have been in the correct pins before. 0 and 1. Okay, yeah. So now they're input pins. So that's 2.7 and the other one's 2.8. Okay, so we're okay there. But now, why is the gate not PWMing? What if I remove the pull up? Oops, I'm in the wrong hole. It's being pulled down. Okay, what if I remove something's up? Because pin 15 is not PWMing. Let me check the code. Morning, Curtis. How are you? Oh, my poor back. Let me check the code. How was your train ride, Curtis? Or are you not done? Are you still... It is pin 15. And, sorry, what pins were we supposed to be on? Yeah, 0 and 1. GP 15, wave share RP 2040 0. Well, it doesn't matter, Jackie, because the average voltage would go up. GP 15 is indeed this one. You know what my problem might be? I'm taking the 12 volt ground, which is fine for checking those things. Oh wait, the 12 volt ground is shared. Yeah, I have a 12 volt ground here too. So yeah, it's not PWMing if I reset it. Yeah, but your average voltage will increase. So let's reset this. So right now 0. And what was the up? I actually want to just check what the up was. I think 0 is up. 0 is up. So if I go here, so that's not doing anything. Oh wait, I have the ground is off now. It's not doing anything. It's not PWMing. But it definitely gets an input here, because when we go like this pin is at this pin definitely is at a logic high, 2.8. So why isn't this working? So the source is ground. The drain is 12 volts. Let's double check that. So between here and here, that's 12 volts. So at the moment, I'm more concerned on why it doesn't read. You've been home for a month. Okay, I haven't been online for a lot, so why is it not reading? Let me check here. Pin up and down are inputs. Pin PWM is output, and again, pin PWM is 15 for sure. So my only problem is, how do I check if it's the Earl Phil Hauer? Library boards. So here, this is installed. But how do you make sure you use it? Catch. Oh my God, I'm not on screen. I'm so sorry. Professional YouTuber, ladies and gentlemen. How do I make sure the Arduino IDE uses Earl Phil Hauer, whatever, RP2040 core instead of some other one? I just sneezed there. You would guess the resistance is too high, but right now there's no resistor plugged into it. Tools board, specific device. It's not useful. Oops, not VS Code. Because see, my problem is right now, look, there is zero. There's nothing installed here. There's no resistor at all. No, Franco, it isn't. So this is what I'm trying to say. Is that I get 1 millivolt. Oops, I'm in millivolts. Okay, so I power on the Arduino. So right now, it's at 0 PWM. Right? There's nothing. So I should be able to increase it by sending a logic high onto pin 0. But look, I'll even do it in a way that doesn't involve the 12 volt at all. I'll just send 3.3 volts directly here. And the PWM is not increasing. So we are going up. The PWM is not increasing at all. So that's ignoring everything else. Our PWM is not working. So something is wrong here. think I'm still logged into Claude. Yeah, it's the coder of the Arduino. We can actually just go back. Doesn't work. Just bench testing plugged into the USB. I just jumper the board's 3.3 volts to pin 0, and the PWM does not increase on pin 15. Everything compiled properly and uploaded properly. Something is wrong. Go through it with a fine-toothed comb, please. I don't think it's the Arduino. Wait, what? There should be no analog read. Analog write? Oh my god, analog read. Why did it do that? Okay, GP 26 and 27 now. Okay, so it was doing, I see what it was doing. I get what it's doing, and although I disagree with it, the logic is sound. It's because it wants to make sure, it wants to set its own threshold. So that's why. Okay, let's check our new code here. Let me just open this up. Okay, so here's the new code. Now up is 26, down is 27. So that should work now. Let's see if it verifies. Oh, whoops. 2040. No, I don't know what serial port. Let me just. Ouch. Oh, that was stupid. I sat on my leg because it's a comfortable way for me to sit. And when I got up, that was quite painful. Okay, so RP2040. I don't see the COM port. All right, let's just upload it because I already put it in boot mode. At least it can be reprogrammed and not a one-shot. Yeah, for sure. So 26 and 27. So we are not going to change anything. We're just going to move what was it? 26 is up? I forgot now. I need my jumper. I wish you would step back from that ledge, my friend. That kind of jumper. Okay, anyways, we're at 0 PWM. So here is 26. There's PWM increasing in the discrete steps. That's at full PWM. And then 27. There it goes down. Up. Down. Up. Down. Oh, missed the down. Down. So it's working. Okay, so that's all fine and dandy, but now we need to redo our, so we need 220. I think this is 220 and then 0 zeros. So that is the gate on 15. Get in there. Okay, and then we're going to pull up. Okay, now we're going to measure what we're getting here. So we have 8 point whatever volts, and then up. These are up and down, and they will go, say up is blue, 26. Down is 27. Okay, so we're at 12 volts right now. And let's go down. And let's go up. Uh-oh, 6 volts. Oh wait, 6 volts is okay. Oh, god damn it. I freaked out. But we're not on the input. We're here. We're after this resistor. Okay. We need to invert the logic so that it starts at 0 volts. Can you stop it halfway? Yeah. Yeah, so here I'll show you. So the up, right now the logic needs to be reversed. All right, so here's a 1 step, 2, 3, 4, 5. And then here is 1, 2, 3, 4, 5. That's kind of perfect. That's kind of perfect. We just need it now to reverse the logic, and then that works. So we've got the input stage working, the output stage working. We've got everything. Everything is seemingly working. I just want to give it a little bit to see if it will overheat anything. I have to find the battery for the thermal camera. Also, it has come to my attention that today is a holiday here in Canada, and I am almost out of creamer. So that is going to be crappy for tomorrow morning. Just want to make sure nothing gets too hot. Just booting up the Unity UTI 720E. So the microcontroller is running at like 30 degrees, but my resistors are all colder than the breadboard. Why is the micro running so hot? Don't know. Shouldn't really matter. But that is it. It is working. Now I have to explain what I came up with. So we'll redo the diagram. I want to use this on camera, so I'm just going to move this to the side. I don't want it off because I want it to keep running to make sure that our temperatures don't go to like 6,000 degrees. So I just want to make this clearer here. So what I'll do is I'll transcribe what is need the naming convention for this stupid MOSFET. Never remember. Okay, drain source. Okay, this is what I'll do. So I'll make the input stage down here. Should probably get like a cloth and clean this. I could probably put a small heatsink on it, but I think it'll be fine. I'm just gonna wait and see. If it fails, it fails. It's actually it is a prototype through and through. And it will be put into production, but if I need to make modifications, if it breaks, I will fix it. Let me just grab some window cleaner here. No. That looks so much better. So I'm going to actually invest in a whiteboard. I am trying to think of somewhere I can hang the whiteboard and have a camera pointing towards it, because it would actually help these live streams, but it would also help other stuff like making YouTube videos. Okay, so we've got here, I'm trying to make this a little bit more compact. So that's the RP2040, and we will have this 3V3, and then we have D15. Okay, so D15 goes to a 220 ohm. So that is 2 20R. And that goes then to a 10K. Dang it. 10K ohm, and then that goes to a MOSFET. Like so, and then a 4.7K ohm resistor here. Like so. And then this will be 12 volts. And then this can go right to ground. And then encircle this, and that is a 2N. 7000. And this goes here. Is that correct? Yeah. But that's not how I have it connected, though. No, I do not have it connected like that. I have it connected like this. Okay, and then this goes off to my signal, like so. Okay, I think that's pretty clear. That's 12 volts, and that's my signal. So that works out. There we go. Okay, now I'm going to fix this. Okay, and now I want my, so we go back to this diagram, and we have up and down, so it's 6 and 7. So we've got our RP. Oh yeah, I want to draw it this way, upside down. Okay, that's the RP 2040. Should mark the inputs. Yeah, that's what I'm doing here. Yeah, you're right. So it's pins 26 and 27. 26 and 27. Stupid part is I forgot to claim this whiteboard on my taxes for last year. 26 and 27, and they both go to voltage dividers. And my voltage divider, I saved it in a document. Where did I save it? Though it would be in, I think it was just on the desktop. Yeah. So I chose 220K and 68K. 220K and 68K. So going to draw plus 12 volts, plus 12 volts. And this is 220K, 220. Why did I do 4? K. And then this is 6, 8, K, R. And then 6, 8, K, R. And this is ground. This is ground. And then, so, actually I should just go 20, which one is up, which one is down? I need to confirm. Up is 26. So actually this is pin up. This is up. And this is down. And then I'll just write 12 volts. This is 12 volts. And then this goes here. And this goes here, which gives us approximately like 2.8. What did my image show? Give us approximately 2.8, yeah, approximately 2.8 volts. And then these are being analog read. So there we go. There's the input stage. There is the output stage. I think that is all. I should review my footage to see what I was missing. But I think it'll be okay. And we do need to reverse our logic. I hope it works too. It looks like it works. Like, I mean, everything looks good. Okay, anyways. Okay, so we need to set up to film now. So I will actually shut down the Raspberry Pi and power supply for now, because I'll film this interstitial. I may actually need to re-explain some stuff. It'll depend. I don't remember what I filmed, but whatever. We will deal with it. I think it might be coffee break time though first. I think I'll do that. I know I lose viewers when I go get a coffee, but it is what it is. I do need to go to the washroom too. I have a little bit of coffee left. But if I take a break now, that means we can continue unbothered. I do have a spot. I have a spot that way that I can put a whiteboard. Might be an idea. Okay, so I will be back after coffee and washroom. So be right back. And I'm back. I did zoom you guys in. Interesting. Here we go. We can put it away. Flipping the LTT store precision screwdriver. I think this is the Pro driver now. They changed the branding. All right. Let's see. So let's make some room and film the interstitial. Actually, I really should check what I recorded last. See. ×8 speed. So I opened it, I took a look, the remote. Took it a pat. Okay, I really didn't do any demo. Okay, so we're gonna film a demonstration on the on using it. Hey, how's it going, Gerald? Yeah, Curtis is here. ITT is here. I'm assuming Curtis is working, and that's why he's not chatting so much. ITT said she was lurking. Jackie was here earlier. Don't know if she's still here. We found the missing Raspberry Pi from yesterday. And by we, I do mean Franco. Franco, when he watched the footage, he mentioned he went back and found our missing Raspberry Pi. Oh, here's the pen. Pen was here. Yeah, hello to the lurkers. By the way, you don't have to participate in the chat, folks. I am happy to have you here, even if you're just lurking. It's all good. The number one thing a YouTuber would like, obviously, I would love if you guys went over to patreon.com/simpleelectronics and supported me on Patreon. That would be great. Some of the people here already are on Patreon. Don't know if they want to be called out. However, the number one thing that I would like is for people to watch. So if you're watching, you're already in my good books. Okay, so we're going to do a demo on how this works. Zoom in, way in. There we go. And maybe I can fit the wiring diagram. I can indeed. Excelente. You don't want to be called out. Okay, I won't call you out then. I won't call your name. Won't call your name. Alejandro. I'm not your babe. I'm not your babe. Gerillo. Okay. Grab these guys. We can turn this on. I'll probably increase the current to an amp. It's good. I don't know if you guys can hear the birds chirping. I've got the windows open. All right. So let's do a quick running demo on how this works. So you got AC in here, so your polarity doesn't matter. And it comes out, I don't know if you can see, but there's numbers on Let's do a quick... Oh my God. Franco! What did we forget? Microphones. That is Franco's fault. He's in charge. Classic Franco. To be fair, Franco is probably asleep. All right, here it goes. Now I am, yeah, okay, now I'm recording. So let's see. So let's do a little demo of how this board works so we know what we're up against. First and foremost, the wires are not colored, they are printed. So here's the 1 and 2, and then all of these channels, 8, 3, they're all numbered. So that's how we're going to refer to the wires. And the 1 and 2 are the power in, that is these two, with the red ferrules. Everything else has yellow ferrules on the end. Now, this is AC in, polarity independent, because it has a full bridge rectifier right there. However, because of the way this thing works, we're going to select one as a power and leave it like that. And I'll show you why. So here I've got 12 volts coming from my Unity UDP 3305S power supply. And as soon as I plug it in, okay, this thing gets started and we're good to go. So now, how this works, if you follow the diagram, 1 and 2 are power. I'm probably going to designate 1 as power in. Then there's a common, okay? And all of what the relays do is they connect to the common or not, right? Relays are isolated, and so in this case, the common, which is number 3, okay, in our case, is probably going to be the plus 12 volts, and we're going to send 12 volts along these wires here, these outputs here. I don't know where I put the remote. Where is the remote? Oh, here it is. Now I've got some AAAs in the remote, so you'll first notice that nothing happens when I press any of these buttons. Because first you have to go start. Oh. So I put some AAAs into the remote, and first thing you'll notice is that nothing happens when I press these buttons except a red LED comes on here. And the reason nothing happens because you have to hit start first, and immediately this first one, this main, okay, over here, that switches on. So that would be like your ignition on. And then when you press and hold start, the RO, so I'm guessing it's the, I don't know, it's the starter anyways. The RO turns on momentarily with the press of a button. Now you can also go through your ups and downs. So up is over here. That's the one we're going to be dealing with, and down as well over here. So basically up and down are 12 volt signals that we are going to interpret with our Raspberry Pi. And then the left and right, they work as is. Don't need to deal with anything in there. Don't know if you can see those. There we go. So everything works. And then if you hit stop, that main shuts off and it goes back to not being responsive. So that is our deal. Okay, good. I'm actually going to turn off Bluetooth. Pairing Bluetooth. How do you... Bluetooth connection disabled. There we go. It's friggin' annoying me this whole time. All right, I'm gonna grab my spare Raspberry Pi. Morning, Lock Watcher. film another thing. My microcontroller of choice, of course, shouldn't be surprising to you if you've been on this channel before. I want to use this Waveshare RP2040 and I want to fit the whole thing in this little cavity here to be in this waterproof box. That's the goal. Now, the problem with the RP2040 is that I can't feed a 12 volt directly to this. So we have to figure out something about the power, and what I have come up with is this. So this is just one of those AliExpress DC to DC converters with a little potentiometer that you can use to select the voltage, the set voltage. And all I did to it is add input and output capacitance, put a little bit of wire onto it, and then put it in this heat shrink sleeving. That's the double thickness with the resin inside. And what I will do is I'll tap into these two wires, making this no longer AC in. I'm going to tap directly into this because this goes to the 12 volt battery on the device. And then it'll feed this, which I've adjusted to 5 volt output. And that 5 volt output will directly power the RP2040 on its 5 volt in. So that is that sorted. Do you like the British terminology? I said sorted instead of figured out or done. Sorted is British AF. I'm actually just going to plug in my other two camera batteries to charge. Okay, so that demo is done. Don't need this anymore, I don't think. There we go. Okay, so now we need to talk about the input stage. So I want this around for like visuals. So let's grab these two and pop them off to the side. Probably should turn off the output on the power supply. Yes, hello everyone. Thank you all for being here. Okay. So this, I probably have to move my coffee. My coffee! Let's move the LTTstore.com screwdriver. Support Canadian when you can, ladies and gents. Okay, so like that. That works fine. Need to put my coffee somewhere else. Okay. Probably will grab focus from here. That's good. Now the next problem we have is that the RP2040 is only up to 3.3 volt tolerant on its input pins. So how are we going to grab the 12 volts, coming from the 6 and 7 here, and translate it to something that the Raspberry Pi won't get destroyed with? Well, this is what I've come up with. So essentially the up, which is number 6, will come through a voltage divider, which is just basically two resistors. So I'm using a 220K and a 68K. It's what I had in stock and what was high enough to limit the current. I really don't need any current, I just need voltage. And that will mean that our input pin is going to read 2.8 volts, more or less. It really depends on the accuracy of your resistors. But no matter how inaccurate these resistors are going to be, it doesn't matter because we are going to do an analog read instead of a digital read. So anything above, let's say 1.5 volts, will give us a logic high. We're going to treat that as a logic high. And so this is the way to do it to protect your RP2040 from ever seeing any higher voltage. Now, if I had more time to design this and I had the proper parts in stock, I would probably put a 3-ish volt Zener diode in reverse protection here, so to ground, so that it would shunt any voltage, it would like lock any voltage that goes above the Zener's reverse voltage. So it would lock any voltage, so it would clamp any voltage above whatever the Zener voltage is, and it would protect the pin like that. But I think this is just fine for now. Even if the voltage creeps a little bit, we should stay below the 3.3 volt limit. So that is the goal here, and that is for both my inputs, number 6 and number 7. And then what do I do for the output? Well, I need to give an... As for the output, my signal wire here, which actually goes to an electronic... As for the signal wire, which I need to feed to an electronic governor microcontroller type thing that is included on the gas engine, it needs to see a voltage between 0 and 12 volts to set the throttle opening. And so here's what I've come up with. If I connect to the positive 12 volts, which I can grab in the box here as well, to a 4.7 k ohm resistor, and then to a 2N7000, which I've got lots in stock, then I can actually have this, then you have this circuit that will always have 12 volts available for the throttle signal. However, when we turn on this MOSFET, then it actually gives it a path to ground, which then will mean that the voltage drop across this 4.7 k ohm resistor will be all 12 volts, and the signal will drop to 0. And anywhere in between, we can handle with a PWM signal. So I am controlling on pin D15, I am controlling the PWM signal of this MOSFET, and we also have a pull-up resistor to make sure that this MOSFET defaults to the on position when the system is booting, so we get a 0 volt signal here. It doesn't really matter because the electronic governor is smart enough to not accept that 12 volt signal on startup, but as soon as the engine is, idling, it will throttle up if it gets the 12 volt signal there. So that's why I want to default it to this MOSFET being on, which means that our signal will be at 0 volts unless we control it to be different. So I think that flew by. I think we got that. That went pretty well. I think that's pretty well explained. Is there anything that's not clear? Like if you guys have any ideas that's not clear. Also, my camera battery is running low. If I turn this off, I can actually charge the camera directly from USB as well, which is something I don't do very often. Let me get a little bit of extra length there. Nah, screw it. We'll just wait till the batteries are topped off in the holder. So yeah, how do you guys think that went? Also, Locke, enjoy your site visit. Wait, if you're visiting the site, are you driving right now or are you actually working right now? Because if you're working, you should probably not be paying attention to me. You should be working. Not that I'm the productivity supervisor. So anything else I have to consider here? Don't think so. I guess what I can do now is I can chop a little piece of perf board to sit here. Let's see what I got in my soldering box. Again, British pronunciation for Franco, who is certainly in dreamland by now, having a snooze. So that is actually almost the right size. I would just need to chop a little bit off of it. It's already almost the correct size. Does it need to be shrunk this way? A little bit. Just a little bit. Okay, let's grab this guy. I have a box cutter knife here somewhere to score this with. I don't know where it went. My jerry rig everything knife. Where'd it go? I miss it so. Let me check in the other room where the other YouTubing happens. Nar? Where'd it go? These are simply questions for the ages. Where did my knife go? I don't know. Where could my knife be? I don't know. Maybe we'll get a shittier knife and change the blade, I guess. Let's do that. Progress must happen. Oh, it's so humid because of the rain. Let's pop open this guy. There she blows. So not my good knife, but a knife nonetheless. Really should get like a shear. That would be cool, huh? Like a sheet metal shear. So let's swap the blade. As you can see, this blade is a little worse for wear. It's been heated. Oh, looks like this side is good though. So I heated up the blade to cut plastic. That was last year when I installed my trailer hitch. Okay, so probably want to take off like 2 to 3 rows. So when you do this, first of all, watch your fingies. Here, I'll zoom you in so if I slice off a finger, you guys will see it in HD. And the other thing is, start with light passes. You don't need to go heavy on it. And then once you've done like a whole bunch of passes, then you can then you can increase the force a little bit. But essentially this is a game of doing more passes, not fewer passes. And then you want to do the other side too. So what are we doing here? This row, I think. Turns out I'm an idiot, so I need guides. Yeah. This one. Should be able to snap that now. Extreme multitasking. Better you than me, my friend. I'm not even good at extreme tasking. Oh no, where do my pliers go? I think this year, when I start making some money, so not now, but at some point, I'm going to invest into a set of tools just for the production here. No more sharing tools with my other self. I actually don't know where my pliers are. There we go. That's one. We're going to shrink that a little bit. Shrinky dink. I went to the side there a little bit. Oh, that's fine. Hope my boss wasn't expecting a PCB-way PCB in this amount of time. Just not feasible. This one didn't quite go deep enough. Well, not exactly the cleanest cut, but a cut nonetheless. Unlike you guys, who are a cut above. When Gerald does projects, his can be Gerald rigged to his advantage. Wow. Do you have kids, Locke? Because that was a dad joke and a half. All right. That's good. I can sand this one too. Okay, how does this fit? Okay, when I take that last row out, I think it'll be perfect. All this fiberglass dust. Probably not great to breathe in. Who needs to breathe anyway, right? There we go. You can trash all this little stuff. And then I'll give this a quick sand. There we go. All right, how does the Raspberry Pi fit? This is not the Raspberry Pi, but it looks like I'll have tons of room for my components to stand up. And then this should fit in there pretty comfortably. And I can even glue this to a 3D printed base or something, or double stick it to the bottom. That's good. Let me just let me go rinse off this fiberglass dust. Okay. There we go. Leave that to dry. That's good. Hand drying. Don't have any towels. For the most part, that's correct. You may want astronaut tools connected by tether. Yeah, that's not a bad idea, actually. I need, you know what, I am getting to that age where I'm starting to think a tool belt might not be the worst idea. Fiberglass dust. Nom nom. Okay, so here's my demo Raspberry Pi. How tall is this? Yeah, because it would be nice if it stood up. Here, I'll zoom you out. I mean, I could angle it like this. I can make a 3D printed wedge so that I can actually like plug in to update firmware. don't ban you. You're old. Yeah, that's fine. Oh yeah. Also have this technique. Here, I got a poll for you guys. Poll. There we go. And answer the poll, folks. Your input is valuable. Okay, so since we don't need this side too, we can actually bias the micro over here. Because we do need the ground. We can actually drop it a little bit too. Because we do need ground. Right? We need, yeah, we need power ground, which we can put onto here. And get our voltage dividers all set up. Let's see if I have different color wires. What kind of wires do I need? So I need 6, 7. I need one for the signal. 12 volts I will grab from the main. I need a couple different colors. I do have an automotive harness. I can go steel. So that's probably what I'm going to do. Let me go steal some wires from my automotive harness. Why do I keep buying snips and then they all vanish all the time? The snips never remain. I am snipless. Where do they keep going? Oh, here's some snips. Okay. Have a good one, Curtis. Thanks for being here. Make sure to vote in the poll, folks. Very important. Oh, God, I'm so old. Okay. Oh. I had to lift something. It was quite heavy. Oh, it's not even the right box. I need the other box. Oh, jeez. Oh, why is this so heavy? That makes no sense. Okay, let's try not to knock this off the box. Oh, jeez. That is heavy. All right, where are you? Here's my wire harness. Need a couple wires. So I've got get a section of pink. I know you guys can't see anything. So I've got pink wire. Get some green. Pink, green. What else can we get? That's green again. I always feel bad about chopping up this automotive harness, but it's literally what I bought it for. I bought it. Literally what I saved it from the trash for is cutting out wires. We got blue. We get some purple. Let's see if we can get one more color. black always useful? Or is that brown? No, not good lighting here, folks. I think it's black. Okay. Ugh. So these were wire harnesses that had rodent damage and were covered under warranty. So I've got all sorts of... I mean, it's such a waste to get rid of these wires, in my mind. Okay, so let's add polarity now to our wires. Oh wait, shit, before we do that, we should probably film some stuff, right? Because we have the working prototype on breadboard, we should probably record that. Okay, so so I want this fully independent. All right, so let's do this. I also need to change the logic. So I need to do this on camera because what I want to do is I want to hook up this directly so the plus is on this side. This is the positive here. Okay, so I'm going to do that on camera. I need some crimping ferrules. Should be around here somewhere. Oh yeah, here are my, these are my ferrules. I need some heat shrink. I need my, oh here's some snips. Snips, stripper, not that kind of stripper. Copper is recycled normally, yes. Wasn't able to interact when demolishing a slab of concrete for some reason. Was that what you were doing? Demolishing a slab of concrete? I knew, you said earlier you were lurking, so I knew you were here. Okay, and somewhere I have Tessa tape. Might be in the car though. So I have the other roll of Tessa tape if we need it. Okay. We need heat shrink. I do like the resin impregnated stuff, but it's a bit more of a pain in the butt to work with. I was hearing a whirring noise, and it turns out when I threw my wires, one of them went onto my power supply fan. Okay, just some generic heat shrink then. Where is my generic heat shrink? Yes, yes, you guys are going to say I have to clean up my workbench. Yes, you are correct. It's what you were doing. Oh, I thought you had an appointment this morning. I thought that's what you said yesterday, but I can barely remember what goes on in my own life, so I wouldn't be surprised if I was totally wrong. So there. Oh, my measuring tape. Well, that would be good. Okay, I'm going to keep the measuring tape somewhere I can find it. This over here. Chabenya babisha baba. I'm gonna take all of my heat shrink and I'm just gonna put it all in a bin. So does this shrink too large? That's the question. Because I might need to get one size smaller than this. You're always wrong, saves time, yeah. Should get a cat. No, I am not a cat person. Mostly because the neighbors' cats are always murdering birds in my backyard. They just let them roam free. Okay, so this one definitely doesn't quite shrink small enough. So I need one size smaller. So yeah, I'm not a cat person because cats are horrible for the environment and people still let them roam outside. They don't care. So I wouldn't bring another cat into this world. Also, one of the neighbor's cats died probably from being eaten by a coyote. And the neighbor's answer was, oh well, we'll just get a new one. This one might be too small. It's going to be very tight to fit over. Yeah, that is life, huh? So yeah, not a big fan of cats. They come and poop in my garden. They kill all the birds that I want to feed and have around. They used to dump animals, like murder squirrels and then dump them into the pool. I think they're a force for evil. Okay, whatever. I'm going to deal with it with the bigger stuff. Okay, so everything is unplugged. That's good. Let's get our microphones. Oh, I wanted to switch batteries. Perfect, my batteries are done. Excellent. We're going to on or off. That's on. That's off. You put the camera battery in the camera. This is difficult. So yes, needless to say, I'm not a cat person. Used to have a cat that would drop out of the ceiling and attack your friends. Yeah, no thanks. I will pass. Okay. Well, that was dumb. Didn't have my microphones. I never said I was bright. By the way, no matter what happens, I'm going to finish stream at 11. That is in 40-ish minutes. Simply because I need to let my back rest. But I will probably be back tomorrow morning to finish it. The issue is that we're doing a video as well as the actual project, so that's why these things take a little bit more time. Yeah, 42-ish minutes. More or less. Like, I could go a little bit longer. It'll just depend on how I'm feeling. Well, I guess it's that time now. Theory is one thing, practice is another, so let's put this together. So I'm going to first install the power supply onto this box, and then from the power supply I'm going to attach it to the RP2040, and once that is done, then I'm going to use my breadboard to make up the circuit and give it a shot, and then that's the only way we're going to know if it's going to work or not. So no going back now. So 1 and 2. So I've decided arbitrarily that pin 1 is going to be plus 12 volts. So let me strip that back, and then pin 2 will be ground, and so we need to connect it to here. Now, I probably will need to have another wire coming off of the ground because we're going to need to ground stuff separately, although this is continuous from input to output. Yeah, so this continues the ground, so I actually don't need an extra wire. I can just grab it from the end of here. So that's good. This is silicone wire, so I can just use my thumbnail to open it up. There we go. And now my favorite way to do this is to use little uninsulated butt connectors, butt crimps. I can hear the giggling already in the comments. But I like uninsulated because it allows you to make a good connection and then go back through and add heat shrink. Now, knowing myself, I'm going to add heat shrink first because I always forget to put it on after. Let's give a nice amount. This is just a single wall heat shrink, nothing special. I'm using this stuff because I need a little bit more flexibility. And this will be already inside of a waterproof enclosure, so I'm not too worried about it touching water ingress. Okay, so I'm going to pick the appropriate butt connector and shake it up so that everything is mixed up. Perfect. So now the important part is we need a butt crimp that will fit 2 wires inside of, and I think that'll be just right. So I'm going to pop this in here. That is a little long on this end. But what I like to do when your ends are a little bit too long is fold it over, especially on the side which will only have 1 wire. So I like to fold that over. You get double thickness. But now you got to be careful because you have to be very accurate on where you crimp it. So I'm just using my iWis crimper here. I have to say these types of crimps that are uninsulated are much easier, less stressful, because you get to crimp your connector directly. You don't have to wonder if you got it or not by looking through the insulation or hoping it didn't pierce the insulation, that kind of thing. And you can also solder this, but I like crimping, especially for rugged applications. A nice solid mechanical connection is best. And actually, if you can go ahead and do both, add a little touch of solder afterwards, that is also a positive thing. Now, a little bit trickier on the other side. We got to make sure we're on the positive. This is on the positive. It's 1 and 1. I'm just going to twist these together, trying to make sure there's no strands sticking out, like so. And then I'm going to set that up in the crimper. I'm sorry if you can't see. I'm not focusing on the camera right now. Focusing on what I'm doing. Nope, need to go a little bit thinner. You want to really put some effort into this. If you screw it up, it can be fixed, so don't worry about that, but you don't want to screw it up. There we go. So that is a strong mechanical connection, and I've even got the heat shrink on there. And so we're going to double check again. Yeah, we're on the positive. That's good. Bring the heat shrink up over both, and then we can do the other one here. So from now on, wire number 1 on this module must be positive. You have no choice. It is now polarized. And this is grabbing the 12 volts directly from the battery. There we go. Give that a tug. And we're going to shrink these down. And then this can plug back in. Like so, and now we have our power connector there. And now all we need to do is to solder this up on the Raspberry Pi side. And on this case, I'll use solder because there's not a good mechanical place to do this, but that might change when this moves from prototype or breadboard onto like a Vero board or a strip board. So we can always just desolder. There it goes, and we're just going to put a little bit of solder on here. And we need to connect 5 volts and ground. And trim up this end here, a little bit too long. And then we want to confirm the positive is indeed this one. And that'll go onto the 5 volt. And this will go onto the ground. There we go. And if this ends up staying on here permanently, I would put a little dab of silicone on here, like caulking, because of the vibration environment. You can't really use hot glue because if this is outside in a 40-degree day, the hot glue is useless. So there we go. That is good enough to test, and the negative is indeed going to the negative. There we go. Hey, welcome back, Franco. Okay, let's see. 42, the meaning of life, the universe. Yeah. Solder won't fix a bad crimp. That is urban legend. No, it won't fix a bad crimp, but it might improve a mediocre crimp. The point is you're alloying to different metals. Old dude sleeps in chair. Yep, that's Franco sleeping. You sleep up to 3 times a day. You're always tired. Yeah, me too. I'm always tired. Okay, so let's put this in my breadboard. My bratboard. I don't know where it went. Franco, I need you to go back and find where my breadboard went. Oh, it's here. It slid down. Okay. So the ground is linked to the 12 volts. The power in. You know what I just thought? I probably would want this not on the power in, but on the main. So if I okay, hang on. So if I leave it on the 12 volts, what's the worst that can happen? Well, it'll drain the battery. let's see how much current it draws. I don't have like a sleep routine, because the problem is if I don't, so 1 is positive. If I make it on the main, if you shut this off, throttle goes up to 100% because of the way it works. Okay, so the problem is it uses 1 watt right now. So it uses 0.2 watts idle. So we need a main switch. We definitely need an on-off switch, because or else it won't work. Because if this is plugged in, so if this is plugged in, it's right now it's drawing a watt. And 0.2 of that is my circuitry. Okay, so we're definitely going to need an on-off switch. There's no doubt about it now. Okay. There's a fuse in here already. It's fused here, but very likely on the main power in, we're going to put a fuse as well. Yeah, that's fine, Lockwatcher. I appreciate you being here. The stream only has like 25 minutes left or so. Okay, so that's fine now. So I just want to make sure everything's good. So 12 volt has to come in here, and we'll take that from the main, I guess. No, this is ground. Okay, so ground. Ground doesn't, I don't need ground anymore. It's grounded to the Arduino's ground. So that's good. So now all I'm missing is the 12 volt output. So from east and west. So that is 8 and, no, up and down, 6 and 7. 6, 7. Okay, so 6 is up. That is 9. 6 is up. 6 is up, and that goes to here, blue. And 7 is down. That's here, and 7. So up and down. And now I'm missing a 12 volt. for the MOSFET. Oh, I can put that on. Okay, that's good. I can put it on the main. Okay, that's good. What's the main? Main is 4. Okay, there's 4. Yeah, it used, yeah, it did. It did, Franco, but now I'm using more. It's just, this is a new system, so it's something we haven't considered before now. On some stream, upcoming stream, I'm gonna have to craft some new jumper leads. I'm running low. Okay, and plug this to 4. Oh, not there. There. This is to 4. Anything else? So now I should be able to check the PWM. I think I'm done with the soldering. That's good. Whoops, the 12 volt is already on. Turn that off. Okay, we need our DMM. Basically, if I get it working on breadboard, that's all I need for today. And then tomorrow we can finish the recording and assemble the board and put it all in place. The blue handles on those cutters remind you of counterfeit channel lock snap ring pliers. Isn't channel lock almost this color already? I think they are that color. Okay, so we can grab ground like anywhere here, and then we'll check PWM. So I can grab ground here like that, and we'll grab PWM probably by probing probe this resistor here. So if I turn that on, okay, so PWM now, oops, it says 0. Okay, so actually when you turn it on, you get nothing, which is good. So if we go start, now PWM should be high, which it doesn't seem to be. Anyways, let's increase it. Something screwy. I need both my hands for this. Okay, so up. What is going on here? Okay, let's check. Let's just check straight up PWM. So 27 should be down. 26. Okay, let's confirm a couple of things. First of all, do we have 12 volts here? We don't. Why don't we have 12 volts there? So the main, number 4, this is number 4. There should be 12 volts here between ground. Here, I'll just pop that in. I can use this ground. Okay, so between ground and let's check here. 12 volts, that's good. Okay, now number 4 should have ground on it. Oh, you know why? I don't have the COM set up. Number 3 also needs to go to 12 volts. That's causing issues. Do we have 12 volts here? We have 12 volts here. Okay, now we have 12 volts here. We have 12 volts here. What do we have for PWM? We have 12 volts now. There we go. We got it. So when I reverse logic, this will be different, but here it is working. That's perfect. 4. You know what I'll do actually? I'll go all the way. I'll just keep the manual range. There we go. So now there we go. So from 0 to 12 it works. Okay, so that is good. We can turn that off now. Okay, and so what we have to do tomorrow is reprogram. So reprogram to flip logic, to reverse logic, and then film, breadboard, design. And then we have to build proto board, version, and then film final version, and then question mark, and then profit. Excellent. So tomorrow then we should be completely done, and that'll be that. But this works just fine for now, and hopefully it'll continue to work. And anyways, I'll keep you guys posted. The client will be thrilled, and my boss will be thrilled as well. There are some unknowns, like maybe this won't drive hard enough for our system. Who knows? But it is what it is. It seems to work now. The poll is still up. Yeah, that's fine. You guys should still hit the like. That's the problem. You guys ain't hitting the like. I don't even know how many likes we have. But anyways, that'll be it for now. I do need to take a break from my back. I have been standing this whole time, and the pain level is like a 2. So that's actually pretty good. But that's it. So it's soon to be lunchtime, which is tacos today. And yeah, I'll see you guys tomorrow and we'll finish this up. Thanks for being here, everyone. I'm glad you were here, and I'll see you tomorrow. Bye.